Good afternoon. My name is Caitlin Green, and this is my blog for the Chapter 4 textbook problems. As you can see here, I do have the clean copy of the questions that we were assigned, but I will be reading from the page that I printed off, which has all of my work and notes on it. So, question 1 shows the times for 20 subjects that are trying to solve a problem on a creativity test, and it wants us to find the sum of squares, the standard deviation, and the variance of the times. So first, for letter A, it's asking us to find the sum of squares, which the sum of squares equation is the sum of x squared minus the sum of x squared in parentheses squared and then divided by n. And the fact of it being in parentheses rather than just being by itself is important because that tells us how to solve the equation. So as you can see here on the first label, on the first ex squared, that's telling us to add up all of these squared numbers. And then ex parentheses squared means that we have to add up all the numbers first and then square them. So on the first step, I took all the numbers, and 11 squared plus 13 squared plus 17 squared for all 20 numbers, and then subtracted it from 809 because that is what the total numbers equal when squared, when added, and then I divided them by 20. So for my first ex squared value, I got 38,597, and I subtracted that from the 809 squared, which gave me 654,481 divided by 20, because 20 is the number of data in that value. And then finally we took, I say we, as if we did it together, but I took 38,597 subtracted from 32,724.05, and I got my sum of squares value to be 5,872.95. Moving on to B, after that mouthful, we then found the standard deviation, which means that we are going to use the equation S equals the square root of the sum of squares divided by n minus 1. And so to set that up, I took S equals the square root of 5,872.95 divided by 20 minus 1, and I got the value 17.58. Now for C, C is fairly easy because it is the same question as, same equation as the standard deviation without being squared. And so it's set up the same, except it's just going to be 5,872.95 divided by 20 minus 1, and we're going to get 309.1 for the variance of the times, or S squared. And then question 2 has to demonstrate that your answer for S is reasonable. And so the mean of the data is 40.45. And when we look at a standard bell-shaped distribution, 66%, give or take, of the data should fall one standard deviation above or below the mean. And so if we go back up here and look at our set of data, 40.45 is the mean. And if we go one standard deviation below, we get 22.87. So just about somewhere here that the number would fall in between. And then one standard deviation above is going to be 58.03, so somewhere right here. So as you can see, almost half of the data is contained within, or over half, of the data is contained with one standard deviation above or below. So that does make it a very reasonable deviation for the data set that we have. Question 3 then asks us to find the actual standard deviation, which is going to be labeled as SD for the time scores. And it is pretty much the same equation as the other ones before. I did this last time too. However, this time it'll just be SD equals the sum of squares divided by n squared, and or square rooted, excuse me. And so we took 5,872.95 divided by 20 and then found the square root of that number, to which we get 17.4. And as you can see, that's very close to the other standard deviation that we got, 17.58, but it's just a little bit smaller. Then question 4 is asking what are the range of the time-scores, which the range is one of the easiest values or measurements to do, but is one of the most unreliable, kind of like the mode is. So I took and did the range equation, which is the x max minus the x min. So I took 64, as you can see for the max, minus 11, and then I got 53. And now we're moving on to question 5, and it says, using the sort and count method, obtain Q1 and Q3, and then find the semi-interquartile range of the time scores. And this question is a little bit more of a step-by-step thing. So for A and B, I use the steps: number 1, address; 2, find the value; and then 3, find the SIR or the semi-quartile range. So first I was finding the address for Q1, which it's a very similar equation as the median address is. However, since we're trying to find the first quarter, it'll be 1/4 instead of 2/4. And then you will see whenever we do Q3, it'll be 3/4. But I found the address for Q1. I took 1 multiplied by 20 plus 1 divided by 4. So I ended up getting 21 divided by 4, which gave us 5.25. Next, I then had to find the value, and so we went back up here and found that the 5th value is going to be 20, and then we have to have the 6th value as well, and that is 27. So then the next step that we do is we're going to take 20, which is the 5th value, plus 27 minus 20, and then we're going to multiply that by 0.25. And for that value, we ended up getting 21.75, which meant that we were good to move on to Q3. And I did the same setup as before. I found the address and the value, which I will then use those values, of course, to find the SIR. So the Q3 address, I did 3 multiplied by 20 plus 1, and then I divided it by 4. And I ended up getting 63 divided by 4, which gave us 15.75. And if we go up here, that's going to give us the 15th and the 16th value, which means that we will get the 15th value to be 55, and then the 16th value to be 56. So we're going to put that in the same kind of setup as before. We're going to do 55 plus 56 minus 5, multiplied by 0.75, and we end up finding the Q3 value to be 55.75. And now we are all good to go and find the semi-quartile range. And I took the equation, which is Q3 value minus the Q1 value divided by 2, which means that we'll have 55.75 minus 21.75, and then we're going to divide that by 2, and I ended up getting the semi-quartile range to be, or semi-interquartile range, I keep forgetting to put the inter, but to be 17. And as you can see up here, see if I can get all of that in there, that is all of my work for the problem, and like I said, we ended up getting 17 for that final value. Now we're going to move on to questions 9 through 10, which are just as equally of a mouthful of work. But we have a stem and leaf graph, and I have all the numbers already ordered, and we have to use these for the next 3 questions. Question 9 is assuming that the test scores will be normally distributed. If a student had a score of 78 on the test, what is the corresponding values? So I had to do a little bit of backbone work before this, to which we know that x, or our number, is 78. The mean of this equation is going to, or this question, excuse me, will be 45.48. And the standard deviation is 22.13. And our equation for the z-score is x minus the average, or x bar, divided by s. So to find the z-score, I took 78 minus 45.48 and then divided that by 22.13 to get 1.47. The t-scores equation, which after having the z-score, all you really have to do is just insert all your values for the last two. So the t-score equation is t equals 10z plus 50. So then I took t equals 10 times 1.47 plus 50 to get a t-score of 64.70, or I guess 0.7. And then the SAT score equation is 100z plus 500. So I took 100 times 1.47 plus 500 to get 647. Now moving on to question 10, which I have this really weird gap here. I'm not sure what that's about. But question 10 asks, if the normality assumption is true, what proportion of scores should fall in between, in which we have A, B, C. And I'll be honest, whenever I was doing this question, I was just a little bit tripped up, but we have those z-score charts that we use for these next few questions. And so what I did is I looked at those charts to find those values. So for A, I got 0.6816, or about 2/3 of the score should fall between one standard deviation above and below. And then beyond z-score of 1.645, I found ended up being in between two values of 1.64 and 1.65, and so we found the middle, which was just 0.05, or I guess the average of those two numbers. And then we did beyond z of 1.96, a negative 1.96, and a z-score of 1.96, and ended up getting 0.05 again. And I ended up making a little Bell distribution graph to also help me visualize where those numbers should fall. And then finally, question 11 asks, to enroll in the follow-up course, a student must be in the top third of the class. Using normal distribution, find the cutting scores required for permission to take the follow-up course. So to do this equation, or to do this question, I use the equation x equals sz, or s multiplied by z, plus x bar, or the average. And so then I took my numbers, 22.15 times z plus 45.5, and then I ended up finding that the z-score to be in the top third of the class would need to be 0.44, and so we took 22.15 and multiplied by 0.44 plus 45.5, and I ended up getting x equals 55.25. And just to clarify, whenever I was looking at the top third, I had to look for the z-score with a 0.33 in the beyond tail, which is how I got the 0.44. So those were my textbook problems for chapter 4. As you could see, for some reason I kept trying to say that we, as in I was teaching you the questions, but I guess that's also a good way to learn, is to try to imagine that you're teaching somebody it. But thank you for watching, and hopefully everything made sense. I'll definitely need to do a little bit of extra work for chapter 4 just to make sure that I'm ready for the quiz this week, but I think it'll all come together. So thank you for watching, and I hope you have a good day. Thanks.